Hi, so in this video we are going to briefly discuss polar covalent bonds. So to get started, we should introduce first the concept of electronegativity, which I'm sure you learned about in Gen Chem. So electronegativity describes how strongly an atom is able to attract or attracts electrons toward its nucleus. Okay, so high electronegativity means an atom really pulls electrons toward itself. And so let's look at some electronegativity values. First we have hydrogen. Hydrogen has an electronegativity value of 2.1. So then we have the first row elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. And so below I'm writing the electronegativity values of these elements. And what you can clearly see is fluorine has the highest electronegativity, lithium the lowest one. So essentially electronegativity is increasing going from left to the right in a row of the periodic table. And we can continue this trend, see, with sodium, magnesium, aluminum, silicon, phosphorus, sulfur, and chlorine. And then below we are going to put potassium and bromine, etc. Now this is just part of the periodic table, but these values here illustrate the general trends. So essentially, again, going from left to right, we have increasing electronegativity. And why is that? Because when you move in the same row from left to right, you're increasing the nuclear charge. Okay, we get more protons in the nucleus, and so the nuclear charge increases, but the additional electrons which are being added to these elements by going more to the right, they are still being added into the same valence shell. And so these electrons now feel an effectively higher nuclear charge. This is why the electronegativity goes up. At the same time, going upwards in the periodic table, upwards to the top in a column, the electronegativity also increases. And this is simply because the valence electrons are going for elements which are higher up, which is a smaller radius. They're closer to the nucleus, and so these electrons feel a higher nuclear charge, and that's why the electronegativity gets higher going up. Okay, so now we can distinguish, based on electronegativity, we can distinguish three types of really different bonds. First of all, we have truly covalent bonds, and there the electronegativity difference is very small, and the electrons are shared almost evenly between the two atoms. So in general, the rule of thumb is if you have an electronegativity difference smaller than 0.5, you can really call it a covalent bond. Typical example would be a carbon-carbon bond, where of course the electronegativity difference is 0. That's super covalent. Now the next class of bonds would really be called polar covalent bonds. And so here, now the electronegativity is larger, and the electrons are still shared between the two atoms, but the more electronegative atom really possesses more of the shared electrons. Right, so that more electronegative atom gets a delta minus charge. For instance, here we would have a carbon-oxygen bond where oxygen is of course more electronegative than carbon, and so oxygen has a delta minus, carbon a delta plus. Now the last category of bonds would be ionic bonds, and here the electrons are not really shared anymore. It's rather that the more electronegative atom pulls all the electrons toward itself. And so the electronegativity difference here is usually larger than 1.7. And so sodium hydroxide, a typical salt, that would be a classical example of this, where the hydroxide is an anion, negatively charged, and sodium is a cation, positively charged. So now this is kind of a black and white picture, but in reality, everything is more of a gray zone. We have lots of gray zones here, so this is a continuous scale of bond polarity. Okay, so that means In general, electronegativity means that electrons tend to shift away from the atom with lower electronegativity going towards the atom of higher electronegativity, right, as we already said. And so again, we have our carbon-oxygen bond. But now, of course, if you have carbon involved in another bond, for example, with lithium, which is less electronegative than carbon, now the polarity shifts the other way around. So here in carbon would will have a delta minus charge, and the lithium a partial positive charge. Now, of course, the greater the difference in electronegativity between the two between the atoms, the more polar the bond. So we can make a table. On the left we have more covalent bonds than polar covalent ones in the middle, ionic ones on the right. And so here again, carbon-carbon is very, very covalent. Carbon-hydrogen is still very covalent. Then it starts to get more polar. We have nitrogen, hydrogen, NH bonds. Carbon-oxygen bonds even more polar. Lithium-carbon bonds more polar. Lithium-nitrogen bonds more polar. And finally, the most polar bond you can have, something among the most polar things, is sodium chloride, okay, which is typical salt. So yeah, again, recapping, on the left we have small difference in electronegativity, so very covalent, while on the right we have a large differences in electronegativity, and things become very ionic. Just to show you one more thing, there's really this gray zone between different categories, right? And some bonds you can call either ionic or polar covalent, and both descriptions are really acceptable, because the bond lies kind of at the boundary between those two categories. For example, a carbon-lithium bond, we can write it either with as a polar covalent bond with carbon carrying a partial negative charge, lithium a partial positive charge, or we can equally well write it as a ionic bond, with carbon being the anion and lithium being the cation. So I will accept both ways of writing these two types of bond, this type of bond. So here, why are both ways of writing the bond acceptable? Because the difference is really 1.5, which is right at the cusp of polar covalent and ionic. So I would recommend that you practice, recognizing polar covalent bonds and ionic bonds and non polar bonds, like purely covalent, with Skill Builder 1.5. Thank you for watching this video.